Hi everyone, Miss Andronicus here, and today we are looking at direct proportion. When there are two quantities in direct proportion, it means that if one doubles, so does the other. If one triples, then so does the other, etc., etc. So here's an example. When purchasing a bottle of water, you know that one is going to be, let's say, 50 cents. When you buy two, it's going to double the price. When you buy three, it's going to triple the price, etc. That is what we call direct proportion. Okay, so one side is multiplied by 3, the other side goes up multiplying by 3. This is a pattern, and of course it also forms a linear graph. If you were to graph it, it would be like a positive trend. So when one goes up, the other goes up by the same proportion. There's a formula for this. We have what we call y equals kx, and y is in direct proportion to x. K is what we call the constant of proportionality. So every time x goes up, it goes up by that constant of proportionality, which means y goes up, let's say. So y therefore always stays in direct proportion to x. It's just like saying when you multiply one bottle of water by 5, the cost then multiplies by 5. And that magic number of 5 is what is represented there by k. You'll notice it very similar to our linear equation, y equals mx plus c. If you think about it, it is actually very similar. The plus c, let's say c is 0 because it intercepted the y-axis at 0, that would essentially get rid of c, and you can see the very similar type of equation. M is the gradient. In this case, if you were to graph this formula, which you can, again, I mentioned that it forms a linear graph, the K would be representative of not just the constant proportionality, but it's actually also the gradient. So that's just something to keep in mind and take note of. Let's go through an example. Y is directly proportional to x. When y equals 3 and x equals 5, the first thing to do is find a formula connecting y and x. Now, straight away, as soon as you see the words directly proportional to, I want you to think of this formula. Y equals kx. So immediately write that down, and you'll see that in this first question for A, it's essentially a substitution, and I've got that little note there on the side in green. So start with y equals kx, substitute what you know. So 3 equals, we don't know k, and it's k times 5. Essentially, you wouldn't write k5, you would flip it around so it looks in that algebraic format. So 5k, fine, substitute, and now we need to solve. So basically we're finding what is k. So divide each side to get rid of that on that side. So essentially, if I start with k, it equals 3/5. I haven't found the formula yet. I've simply just substituted. So now to actually find the formula, remember it's got to be in the y equals kx format. I would have y equals, now that I've found k, I put that in, 3/5x. Okay, that would be your answer to A. That would be the formula. Okay, so essentially you're to find k and then pop it into the formula and present your answer as such. B, find y when x equals 3. Now you have the formula, you simply just need to use it for B to substitute those new numbers in now. So for B, I'm going to start with y equals 3/5x. The question said that x equals 3. Okay, I found my constant of proportionality, so I leave that there. If x equals 3, then I replace x with multiplied by 3, and then I can get my answer to y. And that answer is 1.8. Okay, so basically what we're saying, when x equals 3, y equals 1.8. So you could even think of that as a coordinate. When x equals 3, y must be 1.8 because it is in direct proportion. Okay, so as I mentioned above, you can actually then go and graph this particular formula, because if you compare it to y equals mx plus c, all it's telling you is y equals 3/5 of x, that's your gradient, plus c must be 0. It must be 0, so that's why it's left off. We don't need it there. So that means when I go to graph it, I know that 0 is going to be the y-intercept straight away, and then I rise 3, run 5. It's a positive gradient, so I know I can rise 3, run 5. 1, 2, 3, 4, 5. Okay? Once I've got that spot there, I then can connect my 2 points, and I've connected them there. And so that's the linear graph. Now, the very last answer, I came up with this. When x is 3, y is 1.8, and I can use my graph to check that. So when x is 3, and I can check this point here, it's 3. I look exactly horizontally across and I can see, yes, that is accurate. Y is around 1.8. So I can check that coordinate. When x equals 3, y equals 1.8, and this line is in direct proportion. That's it. Have a go, guys. Thanks.